This is my trigonometry course. Today we're going to learn the law of sines. If you haven't done the homework completely incorrectly from the last class, do that homework before watching this video. The first thing we need to learn is what it means to solve a triangle. When we solve a triangle, we find all three side lengths and all three interior angle measures of the triangle. So in this part of the curriculum, you're going to hear that phrase from time to time. When solving triangles, we encounter 5 general scenarios. The first scenario is when we have all three side lengths of the triangle, but we have no interior angle measures. In that situation, we're going to use something called the law of cosines to find the measures of the interior angles. The second scenario is when we're given the lengths of two sides of the triangle and the measure of the angle between those two sides. In that situation, we're going to use again the law of cosines. The third scenario is when we are given the measures of two angles in the triangle and the length of a side that is not between the two angles. In that situation, we're going to use something called the law of sines, and that's what we're going to learn today, the law of sines. The fourth scenario is when you have the measures of two angles in the triangle and the length of a side that is between those two angles, and again, we're going to use the law of sines in that situation. And the last scenario is a situation where you're going to have some complications, and we're going to cover that in the next class. Now, if you took my geometry course, or if you took any geometry course, you were supposed to learn the triangle congruence postulates and theorems. We learned the SSS triangle congruence postulate, which says that if you have two triangles and the corresponding side lengths of the triangles are all equal, then that information alone proves that the two triangles are congruent. They're the same triangle, same shape and same size. And we also have a postulate for SAS and a theorem for AAS and a postulate for ASA. But if you recall, we did not have a postulate or a theorem for the situation where we have the lengths of two sides and the measure of an angle that's not between the two sides. And the reason for that is because, again, there is sometimes more than one triangle that fits this scenario, and so there's, again, ambiguity. But today, as I said, we're going to focus on the law of sines in these situations. So let's discuss where the law of sines comes from. Now, in this course, and really in the entire math curriculum, generally speaking, you're not really required to know proofs, because proofs intimidate students, they usually bore students, and most importantly, you're just not required to know the proofs of theorems or laws, and so typically they're just not really required. But the explanations for the law of sines and law of cosines are fairly straightforward, so we're just going to quickly show you an explanation for why the law of sines is true. Now, you don't have to understand this, you don't have to prove this, but real quickly, let's just draw an altitude of this triangle. So that is the height of the triangle, and I'm going to call it H. And this corner of the triangle is called B. We also call the corners of triangles vertices, or singular would be vertex. So B is the vertex here. We're going to call the opposite side lowercase b. This angle is uppercase A, so we're going to call the opposite side lowercase a. And that is the notation that we're going to use for the next couple classes to label the sides and the angles of triangles. So that's very, very important. Now I'm going to call this length x, and I'm going to call this length y. So this yellow length is y, and this blue length is x. Now I want you to focus on the yellow triangle. That's a right triangle. And isn't it true that sine A is equal to h over b? The sine ratio is defined to be the side opposite A divided by the hypotenuse. And I'm going to carry this up here. Well, I guess I'll keep it down there for now. Now, isn't it also true that sine B, if you look at this blue triangle, sine B is equal to the opposite side h over the hypotenuse A? Now again, ignore the yellow triangle. We're just looking at the blue triangle. Isn't that true? So now what I'm going to do is I'm going to solve for h in both of those equations. So I'm going to multiply both sides of this equation by b, and we get b times sine A is equal to h. And I'm going to multiply both sides of this equation by a, so we get a times sine b is equal to h. So that was just basic algebra. I'm getting rid of the fractions by multiplying both sides by b over here and multiply both sides by a over here. Now notice that these h's are the same number. They're both the height of the triangle. So I'm going to take those h's and I'm going to set them equal to each other. Now h is equal to b times sine A. But we also know that h is equal to a times sine b. Now, it would probably be easier to understand if we did this in more than one step, but again, you're not really going to have to know how to do this, so I'm just going to do it in a quicker way. I'm going to divide both sides of the equation by AB. And when we do that, the purple B's cancel out, and these A's cancel out. So then we get sine A over A is equal to sine B over B. And that is the law of sines. If you do a similar proof, you can find that sine C over C is also equal to these ratios. So we actually have three expressions in the law of sines. But just be aware that when you actually use this this law, you're only going to employ two ratios at a given time. You're not going to use three of them at the same time. Now again, that was a very short explanation. You're not required to know that. If you set up a right triangle for sine C, again, that shows that the last part is true also. So let's read the law of sines. Now, it's important to understand that this law works for any triangle, not just right triangles. The sine function is only defined for right triangles, but that doesn't mean that you can't use the sine function in this equation to help us find information for any triangle. Again, don't be confused. The sine function is only defined for right triangles, but we can use that function in other equations to help us find information about any triangle. So let's read the law of sines. If lowercase a, lowercase b, and lowercase c are the side lengths of a triangle, and uppercase A, uppercase B, and uppercase C are the interior angle measures, then the equation to the right is true. Now notice we have vertex A down here, and the side opposite angle A is called lowercase a. We have vertex B up here, and the side opposite that vertex or angle is lowercase b. That's how we're going to notate these triangles. I think I mentioned that previously. So that's very, very important. And again, this law applies for any triangle. So that said, let's go ahead and do some practice problems. So, by the way, go ahead and take a picture of these pages. A picture with your phone or a screenshot. And you may want to get a picture of the law of sines close up. And maybe a picture of this close up. So we're going to use the law of sines in this scenario, the AAS scenario. Notice that we have the measures of two angles in a triangle, and we have the length of a side that's not between those two angles. That's AAS. So we want to find the information that is easiest to find first, and because we're given the measure of two angles, the measures of two angles, we can easily find the measure of the third angle. Now, remember, when you're writing the measures of angles, you have to write an M and this symbol here, and we're going to use that notation with the triangle sum theorem. All the angle measures, the interior angle measures in a triangle, they always add up to 180. So this is, just basic review here. But if you have to continue to write this M and this angle symbol for each angle measure, it gets really, really tedious. So mathematicians break the rules. They break the rules and they don't write those symbols anymore. Now you might say, well, wait a second, in geometry we weren't allowed to break those rules, but now we're breaking them. Well, mathematicians do that from time to time. They break their own rules. For example, we learned that the sine inverse function uses a -1 superscript. That's called a superscript. And a superscript in math is usually an exponent. But in this case, even though it looks like an exponent, it actually has nothing to do with an exponent. It's not an exponent. So mathematicians defined their notation and then they broke the rule. They're defining it in a different way, and it's very confusing. But unfortunately, mathematicians do that. So now we're just going to use uppercase letters for the angle measures. We're not going to keep writing this over and over again because it just gets too tedious. So we know the measure of angle A is 20 degrees. We know the measure of angle B is 18 degrees. And if we do the math, we find that the measure of angle C is 142 degrees. So we were given two angle measures, and we found the measure of the third angle. And now all we have to do is find the lengths of these two sides. So it says to find A. We could find C first, but let's find the length of side A first. So now we're going to use the law of sines. But remember, we don't need all three of these ratios at once. We need to choose just two of the ratios. Now we're looking for side A, so we know we're going to use this blue ratio. So we do have to keep that. And we want to find the ratio where we have the most information. So notice that we have side B, and I'm calling that side B up there because it's opposite vertex B. We have the length of side B, but we also have the measure of angle B. So that means that we're going to use this ratio here, this yellow ratio. And we can erase the last ratio. We don't need that. Okay, so we know that the measure of angle A is 20 degrees, and we're looking for the length of side A. We know the measure of angle B is 18 degrees, and the length of side B is 7.3. So now we need to solve this equation to find the length of side A. But I want you to be aware that there are many different methods to solve an equation like this, where you have two fractions that are equal to each other. And teachers typically use many different methods, and because there are so many methods, students tend to get confused. Now, you can use whatever method you want to use. I'm going to show you 4 different methods. Now, usually you only want to show students one method because you don't want to confuse them, but I'm not going to force you to use any particular method. At this level of math, you want to use methods that are quick. You need to start to speed up when it comes to basic algebra. But I'm going to show you all of the methods. I hesitate to do that because I don't want to confuse you again, but I just want you to see that there's more than one way to do this. So just choose whatever way you want to use and stick with that method. But I'm going to show you the benefits and the positives and the negatives of each method. So the first method that we're going to use is the method that is easiest to understand. But the problem is it's very long. You have to write a lot if you're going to show all your work. This is the method that I demonstrated in my beginning algebra course because, again, it's the easiest to understand. So what we're going to do is we're going to rewrite that equation, and I'm going to show all my work here so you can see exactly what we're doing. I'm then going to convert these fractions so that they have a common denominator. So I'm going to multiply both sides of this fraction by 7.3. And I'm going to multiply both sides of the other fraction by a. So we get 7.3 sine 20 degrees over 7.3a is equal to a sine 18 degrees over 7.3a. So notice that we now have a common denominator. And common sense tells us that if these fractions are equal and the denominators are the same, well, obviously the numerators would have to be the same number. So that means we can get rid of the denominators and just say 7.3 sine 20 degrees is equal to a sine 18 degrees. So that method is fairly easy to understand, but you can see that we had to write a lot to get to that point. Now, you don't have to show every single step if you want to use this method. I mean, you can do a lot of it in your head. Okay, so we're at a room. So I'm going to move up here. Remember, when you run out of room, don't panic. You can just use an arrow. And I'm going to rewrite this equation. copy and paste it. And then I'm going to divide both sides of the equation by sine 18 degrees. And what that's going to do is it's going to cancel out these sine 18 degree expressions. So we have 7.3 times sine 20 degrees over sine 18 degrees is equal to A. So now all we have to do is to go to our calculators. Now, if you have a graphing calculator, you're going to enter something like this: 7.3 times sine 20, enter, divided by sine 18, enter. Now, you should get approximately 8.08, and we're going to round off to the nearest hundredth, feet. Remember, you have to write your units. 8.08 feet. Now, if you didn't get that number, your calculator might not be in the right unit. So if you're using a graphing calculator, press the mode button. I'm using a TI-84 Plus, the most popular graphing calculator, and it should say mode at the upper left, and use the arrow keys to make sure that you're in degrees. If you're using an iPhone, you would enter into the calculator 7.3 times 20, then press the sign button, then equals, then divided by 18, then the sign button, then equals, and you should get the same thing. Now, if you got a different number, you may have entered the numbers in the wrong order, but you may also have the wrong angle unit. So at the bottom left in landscape mode, your calculator should say rad. If your calculator says rad at the bottom left, that means you're in degrees, even though rads are not degrees. If the bottom left button says DEG for degree, that means you're in radians. It's the wrong unit. Okay, so we found the missing angle measure, and we found the length of one of the missing sides. So now we have to find the length of the remaining side. And we're just going to use the law of sines again. So sine A over A is equal to sine B over B, which is equal to sine C over C. Again, we don't use all three of these ratios at the same time. We only choose two of them. Now remember, we were given sine B over B. Capital B is 18 degrees, and lowercase b is 7.3. That's this angle, the sine of that angle divided by the length of the opposite side. But now we're looking for lowercase c, so we need to use this ratio. So we're going to erase sine A over A. Capital C, we found that in the first step over here. The measure of angle C is 142 degrees. That's what we found in the first step. And we're looking for lowercase c. Now, again, there are many different ways to solve this equation. We demonstrated the longest method. It's the longest method, but it's the easiest to understand. Now I'm going to demonstrate a method that is probably the quickest method, and that is cross multiplication. We're going to multiply these and then multiply these, and set the products equal to each other. So if we multiply the yellow, we get sine 18 degrees times C. And if we multiply the blue, we get 7.3 times sine 142 degrees. That's the blue product. Okay, so then we're going to divide both sides of the equation by sine 18, and you don't have to show every one of these steps. In fact, you're going to get to the point where you can actually do this in your head, and I'm not going to require you to even show the work, because this equation is just very repetitive. You're going to see it so many times that it's going to get kind of boring. You're just going to see it over and over and over again. So once you get to the point where you can do this in your head, you're not going to have to show the steps on paper. You're going to still have to do the steps in your head, obviously, in order to solve it, but you're not going to have to show the steps on paper. So now we have C is equal to 7.3 sine 142 degrees over sine 18 degrees. So again, if you're using an iPhone, the way that you enter in the numbers in the symbols is going to be very different from a graphing calculator. For the graphing calculator, 7.3 times sine 142 degrees divided by sine 18, and press enter. So 7.3 times sine 142, and then enter, and then divided by sine 18, and then enter. And you should get approximately 14.54 feet. Now, if you're using an iPhone, again, you're going to press 7.3 times 142, then the sign button, then equals, then divided by 18, then the sign button, then equals, and you should get the same number roughly. So we found the lengths of the two sides, A and C, and we found the measure of the angle C. So let's do one more problem like that, and I'm going to demonstrate a couple more ways to solve that basic equation. Now, the cross multiplication method that we used is probably the fastest way, if I didn't mention that. Whereas this method, converting the form of the fractions so they have a common denominator, is probably the slowest method. Now, step number one is to find the measure of angle B. I forgot to write that. So again, the triangle sum theorem tells us that the measure of angle A plus the measure of angle B plus the measure of angle C is equal to 180 degrees. The measure of angle A is 77 degrees. The measure of angle B we don't know, and the measure of angle C is 50 degrees. So if you do the math on that, it comes out to 53 degrees. So very quickly, we've already found the measure of the angle B. So now we're going to find the length of side C, and to do that we're going to use the law of sines. But again, which ratios do we use? Because there's three ratios, but we're not going to use all three of them at the same time. Well, we're looking for C, so obviously we're going to use this ratio. And we have the measure of angle A and the side opposite A, so we're going to use this ratio. So we're going to use these two ratios, and we're going to get rid of sine B over B for now. So capital A is 77 degrees, and the side opposite vertex A is 9 millimeters, and capital C is 50 degrees, and lowercase c, we don't know. That's what we're looking for. Okay, so it's always good to go over what we wrote, make sure we did everything correctly. Looks right. So now we're going to use a method that is actually the general method used for solving any equation with fractions. Well, there are some equations where it may not work, but in most cases when you have an equation with fractions, you're going to use this general method that we're about to demonstrate. It's very similar to the first method that we used, but it's faster. So what we're going to do is copy that equation and paste it. We're going to rewrite it so we can see what we're doing. And I am going to find a common denominator of these two fractions, just like we did in the first step. And I'm going to multiply both sides of the fraction by that common denominator. Now, how do I find the common denominator? Well, you just multiply these denominators together. It always works that way. You can just multiply the denominators together and you get 9c. So I'm multiplying both sides of the fraction by 9c. Now, when you do that, the 9's cancel out and the c's cancel out because we have a 9 on the top and a 9 on the bottom. So we end up with c times sine 77 degrees, and the c's cancel out, so we have 9 times sine 50 degrees. So in each one of these methods, you can see that we get the same result. It's just a different way of thinking about how to do the problem. So now we're going to divide both sides by sine 77 degrees. And we get c is equal to 9 times sine 50 degrees over sine 77 degrees. So by now you should have a fairly good idea how to do this in your calculator. 9 times sine 50, enter, divided by sine 77, enter. And again, your calculator should be in degrees, not in radians. So c is approximately equal to 7.08. And the units are millimeters. So 7.08 millimeters. Okay, so we found the missing angle measure and one of the side lengths that was missing. Now we're going to find the length of the remaining side. So at this point we've used 3 methods to solve an equation like this. We changed the form of the fraction so that they had a common denominator. We used the cross multiplication method, which is actually the fastest method, and then we used this method where we multiplied both sides of the equation by a common denominator. So now we're going to use the fourth method that we're going to learn, but first let's set up our ratio. So again, we have sine A over A, so we're going to use that. And we're looking for b, so obviously we're going to use sine b over b. And if we plug in the information, we get sine 77 degrees over 9 is equal to sine b, and we know b is 53 degrees. We found that in the first step, remember that? We found that b is 53 degrees in the first step. And we're looking for the length of side B. So this last method that I'm going to demonstrate is when we flip the fractions on both sides of the equation. And the reason that we're going to do that is because we don't like it when variables are in the denominators of fractions, because that makes it harder to solve the equation. So I flipped both fractions, and you might wonder, is that really legal? Can you do that? You can do that if you only have two fractions that are equal to each other. But if you have another fraction, maybe you're adding a fraction out here, you can't just flip all these fractions. That doesn't work that way. So just be aware of that. So a downside of this method is that it may develop a bad habit that doesn't work in other situations. Now, why is it that you can flip both sides? Well, in order to show why this works, or to prove that it works, that it's mathematically sound, you would have to generate complex fractions, and it would take a while, so you don't really have to know why it works. But at this point, we can simply multiply both sides of that equation by sine 53 to solve the equation. So I'm going to copy that equation, and I'm going to multiply both sides by sine 53 degrees. So let me shrink this a little bit. So these sine 53s cancel out, and we're left with b is equal to 9 times sine 53 over sine 77 degrees. So now, again, I'm going to use a graphing calculator. 9 times sine 53, enter, divided by sine 77, enter, and we get 7.38. And the units are millimeters. Don't forget your units. It's very common for students to forget their units when they're doing these problems. So we found the two missing side lengths and the one missing angle measure. So we solved the triangle. So now it's time for you to try a problem. Go ahead and get a screenshot here if you haven't already taken a picture of that information, and take a picture of the first problem that we did. That'll help you, and you can use problem number 2 to help you do problem number 3. So remember, you're going to start off by finding the missing angle measure using the triangle sum theorem, and you have to choose which ratios you're going to use. So go ahead and try number 3. When you come back, we'll do it together. Okay, we're back. Now, you don't have to write this equation every time you do these problems. You don't have to do that. I'm just writing it so we know exactly what's going on here. Okay, so now let's do the math. If we do the math, we get 43 degrees. So the measure of angle A is 43 degrees. If you got that one right, good job. So now let's find the length of side B. So obviously we're going to use sine B over B because we're looking for B. And we know the measure of angle C and the length of the side opposite. So we're going to use sine C over C. So now if we plug in, we have sine 92 degrees over B is equal to sine 45 degrees over 30 inches. So at this point, again, you can use any method that you want to use, but if we have to demonstrate the method over and over and over again, it's just going to become very boring to you. So at this point, I'm just going to do the math in my head, and you can practice using whatever method you want. And again, once you become comfortable with this, you can start to do these problems in your head also. It's a lot easier than you think. So we're going to get 30 times sine 92 degrees over sine 45 degrees. So the method that I'm using in my head is the cross multiplication method. It's just the fastest and easiest way to do that algebra in your head. So 30 times sine 92, enter, divided by sine 45, enter, and we get 42.4 approximately. 42.4 inches. So if you got that one, good job. But we still have to find the length of side A, right? So obviously we're going to use sine A over A because we're looking for A. And remember, we have this ratio sine C over C. So sine 45 degrees over 30 inches. Whoops, I'm going to write that out first. Sine C over C. And A, capital A, is this number we found in the first step. So let's double check all that, make sure it looks right. Again, I'm not going to show all of the steps because it's going to get too tedious to have to see that over and over and over again. So just choose whatever method you want to use. You can go back to the screenshots and you can write it out. But if you feel comfortable doing it in your head, you can also do it in your head. So 30 times sine 43, enter, divided by sine 45, enter, and we get 28.93. And that is inches. So if you got that right, excellent. Okay, so you can take a picture of these two problems if you want to, and you're going to use that picture to help you do problem number 4. So please try problem number 4. Find the measure of angle C in the first step, and when you come back, we'll do it together. Okay, we're back. Again, you don't have to write out this triangle sum theorem equation. So C, capital C, is equal to 148 degrees. So if you got that right, good. Now, obviously, we're going to use sine A over A in the law of sines because we're looking for A. And we're going to use the ratio where we have all variables given, and that's sine B over B, because we know that capital B is 22 degrees, and we know lowercase b is 87 centimeters. Now we know sine A is sine 10 degrees, and we're looking for A. So if we solve this equation in our head, we get 87 times sine 10 degrees over sine 22 degrees. Now, if you're not comfortable doing that in your head, you don't have to do it in your head. You can use an intermediate step. When I first learned this stuff, I was not comfortable doing that in my head either. So it's okay. But as time goes by, you're going to find that you're going to be more and more tempted to actually do that in your head. And you might make a mistake, but that's okay. Your mind will naturally start to figure out how to arrange the symbols so that you can do the algebra properly. So 40.33 centimeters. So if you got that right, excellent. But we still need to find the length of side C. So because we're looking for side C, obviously we're going to use the ratio sine C over C. And because we have a lot of information in this other ratio, sine B over B, we're going to use that. So the measure of angle C is 148 degrees. We found that in the first step. And we're looking for the length of side C. Angle B is 22 degrees. And side B is 87 centimeters. So C is equal to 87 times sine 148 degrees over sine 22 degrees. So 87 times sine 148, enter, divided by sine 22, enter, is 123.07. centimeters. So if you got that one right, perfect. Good job. So all of the problems that we did were the AAS scenario. What that means is we were given the measures of two angles in the triangles, and we were given the length of a side that is not between those two angles. In that scenario, we use the law of sines. But there are three scenarios where we use the law of sines. In fact, there's we use the law of sines in even more of the three scenarios. We just don't use the law of sines in the first step in all the scenarios. But the other scenario is the ASA scenario, where we have two angles, in this case angle A and angle C, where we know the measures, and we have the length of the side that's between those two angles. Now in this case, again, we do the easiest thing first. We just find the missing angle measure, because we already know the measure of two angles. So we know the measure of angle A and the measure of angle C. And so the measure of angle B is 54 degrees. So far, this problem is pretty much the same as the previous problems that we did, and actually it's really the same problem. There's not much difference when you have the ASA scenario from the previous scenario, AAS scenario. So now we're going to use the law of sines, and we're looking for side C, so obviously we have to use that ratio. And here's where there's a slight difference. In the second step, we're going to use the angle that we had to find in the first step, whereas in the other problems we found the angle, or we used the angle that we found in the first step in the third step. But again, it's really just a minor difference. So we're going to use sine B over B. So we found capital B in the first step. That's 54 degrees. We know the side opposite B is 56 miles. And we know that angle C is 31 degrees, and we're looking for side C. Okay, so let's solve for side C, and we get 56 times sine 31 degrees over sine 54 degrees. And now we can use the calculator to come up with a rounded off number. So 56 times sine 31, enter, divided by sine 54, enter. And we get 35.65. miles. So again, it's just like the previous problems. And now we're going to find the length of side A. So obviously we're going to need the sine A over A ratio. And we have this information. So we're going to use sine B over B. So B is 54 degrees. We found that in the first step. And the side length opposite, or the length of the side opposite, is 56 miles. Capital A is 95 degrees, and we're looking for the length of the side opposite, that angle. So A is equal to 56 times sine 95 degrees over sine 54 degrees. So 56 times sine 95, enter, divided by sine 54, enter, is 68.96. Miles. So again, that problem was really not much different from the previous problems that we did. Now this is just giving you more practice. If you're starting to feel that this is a little bit repetitive, you're correct. These problems are a little repetitive, but we're learning how to use the law of sines. Okay, so get a picture of number 5. And I want you to go ahead and try number 6. I think you have enough to do this problem. Again, these ASA problems are pretty much exactly the same as the AAS problems. So try number 6, and when you come back, we'll do it together. Okay, we're back. So again, you don't have to write this triangle sum theorem out. If we solve for A, 180 minus 138, and then minus 32 is 10 degrees. So the measure of angle A is 10 degrees. If you got that right, good job. So we're looking for the length of side B, which means obviously we're going to use the ratio sine B over B. And we have to use this angle that we just found in these particular problems. So we're going to use sine A over A. So the angle we just found was 10 degrees. That's capital A. And the length opposite that angle is 43 meters. 43 meters long. And angle B is 32 degrees. And side B is what we're looking for, the length of side B. So B is equal to 43 times sine 32 divided by sine 10 degrees. So now we're ready to estimate the answer with our calculator. 43 times sine 32, enter, divided by sine 10, enter, is 131.22. And the units are meters. So if you got that right, perfect. So now we're going to find the length of side C. And because we're trying to find the length of side C, obviously we're going to use the ratio sine capital C over lowercase c. And we know this ratio, sine A over A, so we're going to use that. So that's sine 10 degrees over 43. Is equal to sine C, and C is 138 degrees, over side C. So if we do the algebra, we get 43 times sine 138 over sine 10 degrees, and using our calculator, 43 times sine 138, enter, divided by sine 10, enter, is 165.69 meters. So at that point, we've solved the triangle because we found all three side lengths and all three interior angle measures. So if you got those answers, excellent. So I want you to try one more of these problems, problem number 7, and when you come back, we'll do it together. Okay, we're back. So we're going to use the triangle sum theorem, of course. You don't have to write that equation, as I mentioned. So we're looking for the measure of angle C. And if we do the math, we come out with 77 degrees for the measure of angle C. And we're looking for the length of side A, so obviously we're going to use sine A over A. And we have the measure of angle C, so we're going to use that along with the length of side C. So the measure of angle A is 63 degrees. And the measure of angle C we found in the first step is 77 degrees. And the length of side C is 17 feet. So doing the algebra in our head, we get 17 sine 63 degrees over sine 77 degrees. So if we use our calculator, 17 times sine 63, enter, divided by sine 77, enter. And we get 15.55 feet. And make sure you write feet. If you didn't write feet, go back and write feet. You need to write your units. So now we're looking for the length of side B, so obviously we're going to use sine B over B. And again, we're going to use that ratio where we have the most information. We know the measure of angle C is 77 degrees, and the side opposite C is 17 feet. And we know capital B is 40 degrees, and we're looking for the length of side B. So if we do the algebra in our heads, we get the following expression. So now we go to the calculators. 17 times sine 40, enter, divided by sine 77, enter. And we get 11.21. And that is feet. Again, you must write your units. If you don't write your units, then you would lose points on a test. So if you got those numbers, excellent. Good job. So as you can see, these problems are tedious. They take a while to solve because you have to do, it's really a multi-part problem. Each problem has multiple parts. So they take a long time to solve, but you're just using the same math over and over and over again. So I'm not going to make you do any more of these problems, at least not in class. Of course, for homework, you're going to have to do some practice problems. But that was the class today. If you'd like to take screenshots of all the work that we did to help you with their homework or to study for tests, go ahead and do that now. Here's the first screenshot. And screenshot number 2. And number 3. Number 4. And number 5. But don't go before you get your homework. Here's the homework. Screenshot number 1. And number 2. But don't go before you get the answers. Remember, you have to make sure that you do the homework correctly. So there's a screenshot of the answers. So get that homework done completely and correctly. And remember, if you don't do the homework, it's 100% guarantee that you're going to learn absolutely nothing in this entire course. So get that homework done, and I'll look forward to seeing you in the next class.